Hello, everyone. Warm welcome to the Engineering, Products, and Technical Program Manager Talks. Shout out to Knowledge Creations 1000X. Um, in the next two talks, I want to continue our deep dive into the X, formerly known as Twitter, system design. In the previous talk, I looked at the system interview framework, and we're essentially applying that system interview framework to the design of Twitter. And we will do this for other popular systems as well. Stay glued to your seats. Okay, we like to start with a thought of the day. Any Pinky and the Brain fans out there? If there are you pondering what I am pondering? Well, what I'm pondering today is from E.M. Forster, who says, death destroys a man, but the idea of death saves him. So he says, death destroys a man, but the idea of death saves him. I think what this says to me, at least, is we should do all we can while we can, because tomorrow is not guaranteed. If that is it, let me save you by progressing. P.S. If this says something else to you, this gives you a different ambivalence, a different feeling, direction, please let me know. Let me know in the comments below. Okay, so in part two, we are, so in part one, we covered the introduction to Twitter, requirements and goals of the system, capacity estimation and constraints. We've said if you have an interview coming up, this is really for you. But we've also highlighted the fact that early career opportunities are drying up across the Western world, and um, even top US employers are, in their attempt to cut costs, are having flat head counts. And what this means is that things are a bit more fierce in terms of jobs and job interviews. And my hope is that these series of videos will help particularly TPMs, technical program managers, engineering program managers, to get ahead in that race. Okay, so we're going straight into the system API design. Now, one good tenet of system design frameworks is once you finalize requirements, you want to start defining the system, right? You want to start defining the system parameters, uh, explain what you expect from the system, what the system will provide to your customer, right? In a separate discussion, I will talk about API architectures, the difference between SOAP and REST, when they are best applied. But for the Twitter or X, formerly known as Twitter system design, in terms of the parameters, right? So our system interface for a tweet will require an API dev key, will require the tweet data. We discussed that just previously. If you rewind 1 minute, a location for the tweet, right? So the API dev key, you could ask, what is that for? So the API developer key of a registered account, what that does is that it helps you throttle users to ensure that your system is not overwhelmed, because you allocate um, each user an allocated amount of tweets that they can give per second, per minute, whatever that is. But it's good to give that, or else your system is not under control. Um, the tweet data would capture the text of the tweet. We've said for our system is 140 characters, although we know the real X now allows much more characters. We said the tweet location, this should be a string. And what this does is it captures the location, whether it's longitude or latitude that the tweet refers to, the user location, the same thing for the user. We are also defining media IDs, right? And the reason why I think this is important is that it gives you an optional list of, the media IDs that can be associated with a tweet, right? So think of photos, videos, coding sheets, that need to be uploaded separately. They need to be uploaded separately. They need to have a media ID so that you can configure them to each tweet, right? And what does this return? It would typically return a string, right? So a successful post will return a URL to access that tweet. Okay. Otherwise, the appropriate HTTP error is returned. Of course, this. Okay. So that the parameters I just talked through, and that's what we say it returns. Okay. So the next thing we need to do is we look at the high level system design as we design from the system level framework, right? So we've already said that for our system, we need to be able to efficiently store uh, roughly 1100 tweets per second, right? And we should be able to read roughly 650,000 tweets per second. So obviously from the storage to the read, you can tell that this is going to be a read heavy system, right? Because more people will be reading than will be posting. So at a high level, right? Big boxes at a high level, we should need multiple application servers to serve all these requests with most likely load balancers in front of them for traffic distribution. At the back end, we'll need efficient storage, an efficient database that can, store all the new tweets and can support a huge number of reads. So therefore, that means the retrieval rate has to be high, the round trip time has to be low, round trip time has to be low. I will come to the evaluation of the latency later. We also need some file storage to store both photos and videos. Yeah. Now, although our expected daily load is 100 million tweets and the read load is 56 billion tweets, um, we we know that the traffic is going to be distributed at different points of the day, right? So for system design, we make an average calculation, but in reality, facts on ground, facts on facts on facts, there'll be peak times depending on the country, depending on the different countries will spike, right? Obviously, different countries come to noon at different points. Also, different countries will have different cultures that determine, or different users that determine when will be peak and when will not be peak. So even though we expect, say, 650,000 tweets per second, we need to design our system to be more than that, right? It has to be a bit higher. Say, for instance, 1 million tweets, 1 million read requests per second. This is because of those peak times, right? Sometimes it'll be high, sometimes it'll be low. 650,000 is the average spread across the 86,400 seconds that make a day. Okay. And the only reason I'm saying this is that you just need to keep this in mind. Because someone could say, hey, I've designed my system for 650,000 tweets. That's all. What I'm saying is that no, that's not all. It's not oversizing your system, but you have to add some margin to your system design. That's what this is saying. Okay. In terms of the design itself, these are the typical client load balancer application, database pattern, 3-tier pattern. Okay. So these are clients at the top level. There'll be load balancers to distribute traffic, which are these application servers. There'll be databases, we'd expect file storage. Okay. And then a question that you have is, so what would the database schema look like? Okay. I've said that in the early stage of the interview, you want to define how you believe the database should look like. And the reason why is that it helps you understand the data flow, how data flow among various components. So now we've defined 4 components here. There's the tweet itself, which is going to have a tweet ID, user ID, content, 140 characters, remember, uh, creation date, date time. The user will have a user ID, name, email, date of birth, creation date, uh, the user follow, right? So user follow, you want to be able to capture a join to say this user is following that user, the primary key. And then you want to have a favorite, right? Now, a straightforward approach for storing the above schema would be to use a relational database, RDBMS like MySQL, since we require joins, but uh, relational databases, they come with their own challenges, and you can look at my video, SQL versus NoSQL, and there are lots of literature comparing the two, right? We can store tweets in a distributed file storage like Hadoop, HDFS, or even Amazon's S3. We can store the schema in a distributed key value store as well. That's one way to enjoy the benefits um, that you gain from a NoSQL database. All the metadata related to tweets they can go to a table where the key would be the tweet ID, parent key will be the tweet ID, and then the value will be an object containing tweet location, user location, creation timestamp, etc. Right? Now, NoSQL stores typically maintain, a certain number of replicas to offer reliability, um, and in such types of data stores, like NoSQL data stores, you know, deletes will not be applied instantly, gives you time for quick recovery, and data is typically retained for some time to allow you uh, on delete if that needs to happen, right? Okay. So just to recap, in part one, we covered introduction to Twitter, requirements and goals of the system, capacity estimation and constraints. And in part two, we've just covered system APIs. We've looked at the high level system design, and we've looked at database schema. In part three, the we'll look at the sharding, how we want to shard data, how we implement a cache if that's necessary, and then other things like observability and monitoring. As usual, I'll say please like and subscribe, and let me know if you would approach the system design differently. So far, so good.